Hello, we are Team 45 and we were tasked with making a design for our client, Team 44. The description we were given by our client was a machine that could sweep a small object towards itself into a compartment. The machine should be able to sweep something 6 inches in front of it. The object that is being swept will be no larger than a golf ball. The machine should be able to repeat and reset. And after the sweeping motion has occurred, a person should be able to reach into the compartment and take the object out.
After being given these specifications, we had a few more areas that we were looking for clarification. Our questions were, 1. How did the machine stop, as in, is it user interference, an autonomous stop, timed, or keyboard interrupt? The answer was that it is an autonomous stop that will occur after the object is swept in. Another question we had was, will there just be one object, or if there are multiple, can we do them all at one time? The answer here was that there will be multiple objects, but at different times. The objects will be replaced after each time the arm sweeps an object in. We were also wondering, will the object always be round, which the answer was yes. And we were curious about whether the code needed user input to start, such as every time a button is touched that the program runs, or could we just run the program? We made a technical needs chart, which was as follows. One qualification of the technical needs chart was that it needed to sweep the small object towards itself. To do this, we were looking for something that would be able to rotate a hooked arm about approximately 180 degrees. Another thing was that it needed to be able to reach 6 inches in front, and our target value for this was that it was able to reach anywhere from 6 to 8 inches in front of itself. The last qualification was that the user needed to be able to take the object out of the machine's compartment, meaning that it needed to be large enough to fit one's hand, and so our target values for this were that the dimensions were at least 5 by 7 inches. Further notes from the client were that the object will not be larger than a golf ball, and that the code can be stopped and reset in between rounds.
When the program begins, the motor is first moved to a position of -10, then paused for 0.5 seconds, and then it's set to a motor power of 35 so that we don't over push the ball. The program is then run for 2 more seconds before the motor power is set to 0, and the arm is then pushed back out to motor position 10 so that the next ball can then be placed down. When designing the project, there were several alternatives that we went through, one of which was using a motor to rotate a belt of some sort, or to have a sweeping mechanism push objects towards the compartment, to have a conveyor belt again to push the object, to have a sideways arm that runs parallel to the ground, an upright arm that is perpendicular to the ground, or a motor that would be purely controlled by position and not power. In the end, we decided to go with having a sweeping mechanism to push the objects towards the compartment that relied upon motor power, as well as position.
Our final prototype is shown in the image in this slide. We have a motor setup on the left side of the compartment where the arm is attached there. The arm is approximately 8 inches long, and it is used to direct the ball, which would be placed right in front of the compartment. The compartment is roughly 7 inches by 5 inches, and once the ball is pushed into the compartment, the user should be able to reach in and grab the ball. This is more evidence that our system meets specifications. It is shown through a video. As shown in the video, the 2 balls were swept into the compartment, and then the user took the balls out, meeting the specifications from the user. As demonstrated in the previous video, this machine is able to reliably guide several balls into the compartment, which is approximately 7 by 5 inches, reach balls that are roughly 6 inches away, and provide easy human access into the compartment. Overall, our design meets the specifications, and Team 45 would consider this a success.